Um, on the majority of the work that I give you, let me move this stuff over. It's going to be like the sheet I gave you yesterday. If I give you the name of a compound, I want you to write the chemical formula, and then vice versa, right? Now, the reason I say this is because there's like one or two exercises in the textbook where they just tell you what the elements are and want you to give both, like we did on the board yesterday. It's not really a big deal. All right. On number one, it was BaCl2. Landon, do me a favor. Yes. Let's go ahead and hand this back. Oh, Landon. There's more. Hang on, stand up here. Let me make sure it's on. Yeah. Yeah, just go ahead and hand those back. All right. We got a chemical formula. Okay, first of all, this is ionic, and I know it's ionic because if it's ionic, that is the cation, the positive, and it will be either a metal or a polyatomic ion. And we'll go over polyatomic ions as we get to it. Okay? This is going to be either a metal or a polyatomic ion. Okay? Polyatomic ions are listed on table 1, page 226. And then the second thing in this formula will always be an anion. And it will always be either a nonmetal or a polyatomic ion. Okay? When we write the name of an ionic compound,
That's when you show them? Yeah.
okay. Hey, when you're writing the name of an ionic compound, it does not matter how many atoms are there. You on your cell phone? It doesn't matter how many, it just matters what the name is. So that's all you put is the name.
For what?
For the ionic compound. So the cation, you just write the name. You just write the name. Hey, another thing. How many elements do you see here? Different types of elements? Two. We are doing names and formulas for binary ionic compounds. One kind of cation. That means one type of cation and, bless you, one type of anion. Okay? So if you see just two element symbols, they're both on the periodic table. If you see three or more symbols, means something like this. Let me go ahead and put this on there. I gave away all the sheets. I got one of you. Like number 4. Look at number 4. How many element symbols do you see here? 3. That should tip you off that there's a polyatomic ion. what I mean when I write PA9. We'll get to that in just a second. Okay, so for the cation, you just write the name. So what is the name of Ba? Barium. Now, the anion. If the anion came from the periodic table, which this one does, it's chlorine, right? Remember, you have to take off the end of the name and put the suffix IDE. So that would be chloride.
So it's the last element that you have to do that?
Huh?
It's the last element that you have to do that?
Mm-hmm. Yeah. And if the last element is on periodic table, you do that.
How do you know if it's not?
I'm about to show you. When we get to number 4, you'll see. Okay, now let's move on to number 2. Li3N. Li3N. Okay, once again, I look at it. How many element symbols? 2. So that means they're both on the periodic table. So I look at the name of the first one on the periodic table. What is it? Okay, so you just write lithium. Now, the second one, remember, you got to take off the ending and put IDE. If you will look on page 221, I think. Page 221. Table 1, it gives you the spelling for those. Okay, so what would this one be? Good, it would be nitrate. That IDE, and it being just one element symbol, tells you that it's on the periodic table. It's just a nitrogen atom that has gained 3 electrons to fill its octet. Okay, now, number 3. Number 3. I missed this one a second ago. Okay. Can I help?
Like, can it be, like, say it's phosphorus, if it's phosphate or it's phosphide?
Okay, if it's on the periodic table and it's just a P, then it's going to be phosphite. If it ends in ate or ite, like phosphate or phosphite, it's on page 226. It's a polyatomic ion, and we'll get to that we're getting there now, as a matter of fact. We're getting close to it. Okay, everyone, how many element symbols do you see? 3. So remember, that means there's a polyatomic ion. So we got to figure out which one it is. Look at Na. Are there any, look on 226, table 2. Are there any polyatomic ions that have Na? Just scan through there. Okay, so like if this were my first day of learning how to write this stuff and I sat down with this, I'm showing y'all what I would do. I would scan table 2, look for a polyatomic with Na. There's not one. That means Na stands alone as an ion, right? And if it's standing alone as an ion, it's on the periodic table. So then I go to the periodic table, and then I find Na, sodium. So I write sodium. Now, and remember, we're dealing with binary, only 2 types of ions. So that means this has to be a polyatomic ion. So I look on 226 and I find OH, hydroxide. That's the thing. With the polyatomic ions, you don't change their name. You just write what the name is on page 226. So this would be hydroxide. Number 4. Okay. Now Now, this one's easy to pick up on because there are the parentheses. So that tells you what the polyatomic ion is, right? Okay, so that means Ca is on the periodic table. What's the name of it? Calcium. Now we look on 226, and what is the name of the PO4? Phosphate. Angel, do you see the difference? Okay. And while we're here, let me go ahead and point something out to you guys. Any polyatomic ion that ends in ATE or ITE contains oxygen, the oxygen atom. Okay. So when you see ATE or ITE, you think polyatomic without oxygen. But for now, you can just look on 226.
So, like say H2O, so if it's not a polyatomic ion, you would look at H221.
Yeah, or the periodic table.
So hydrogen, what about the O?
Well, H2O is molecular,
So,
and we're going to get to it next week, about Tuesday or Wednesday. So it has a different set of naming. Remember, ionic, Angel, if it's ionic, you tell if it's ionic if the first element is either a metal, remember left side of the periodic table, except for hydrogen, or a polyatomic ion. That means you use these ionic rules to name and write formulas, okay? Molecular, whole different set of rules, and we'll get there Tuesday or Wednesday. And it's a lot easier than this. Once you get this done, we're on the downhill slope. Okay, ionic is the toughest part of this chapter. Okay. Number 5. Okay, don't say anything yet. If you have not answered it, take a moment and figure out the answer, and let us know when you get done.
So do you focus on the subscripts, you just focus on like
Just the name, just the identity. And I'll give you a preview. We focus on the subscripts on molecular, but not ionic. Okay, y'all got it? Okay, what's the name? Very good. Calcium oxide. Okay, so that's writing names. The other half of the homework was asking us, it was giving us the name and asking us to write the chemical formula. So on number 6, strontium nitrate. Okay. The cation is just the name of the cation. Is strontium on the periodic table? And when we get through all the element quizzes, or at least the first 2, that will help tremendously because you'll know it.
Yes.
Yeah, it's on the periodic table. Okay, and before we can write the formula, we need the symbol and we need to know the charge of the ion. So SR, right, is the symbol. Now, for the charge, right, let me tell them because they weren't here yesterday. Look over there on the chalkboard and look on the inside back cover of your book. It should be written at the top of the groups. Now let's think about strontium. Strontium is in group 2. It has 2 valence electrons. In order to satisfy the octet rule, remember what octet rule? Okay, strontium can either get rid of 2 electrons or it can pick up 6 to fill that energy level. So what do you think it will do? It'll get rid of the 2. Now, when it gets rid of 2 negative electrons, that means it's now going to have 2 more positive protons than it does negative electrons. So that gives it a charge of +2. So this is now an ion with a +2 charge. And over there on the chalkboard are the rest of them. We do not include group 14 because 4 valence electrons is halfway to an octet. Does it gain or does it lose? It shares. So it'll be in molecular. And the D block, my hope is to get to it in just a couple of minutes. But you will feel better about this stuff if you get this sheet, mastered, really get a handle on this. Then we'll deal with D block. Okay. The anion. Remember, ATE, that's a hint. ATE means it's a polyatomic ion. So you go to 226 and you find its symbol and its charge. And let me say this, for everyone who was here yesterday, it won't hurt to review, okay, to get these guys up to speed, right? Okay, on a symbol, fellows, okay, some ion symbol, right? If you have a superscript, the superscript tells the ion charge, and the subscript tells the number of atoms or ions. So subscript tells the number, how many, and the superscript tells what the ionic charge is. So when we find nitrate for 226, what's the symbol?
NO3.
NO3, and what's the charge? -1. Look at it again. If there's a line up there that's a negative, 1 is never written in chemistry. It's understood. If you don't like that, put the 1 there. That's okay. No biggie. Okay. No, it's not the answer. We're getting there. Now, here's the catch. Universe says an ionic compound has to have an overall charge of 0 for it to have lowest potential energy and be thermodynamically favorable, which means universe liking. Its overall charge has got to be 0. So look at this. How many positives and how many negatives need to combine to get 0 overall?
1 negative.
Yeah, you're one.
1 positive, 1 negative.
Okay, if we take 1 strontium,
So you need 2 of nitrate. So for every strontium, you need
yeah, but yeah, let me demonstrate something real quick. If we took just 1 of each, what kind of charges combine? A +2 and a -1. Does that equal 0? No. Universe no liking. So what does it need?
One strontium, two nitrates.
needs 1 strontium and 2 nitrates, then it's stable. So, here's the answer. SR NO3, yeah, let me show you why we do parentheses. If I just put a 2, y'all watch me for a second. If we just put a 2 there,
32.
well, it's not 32 oxygens, and that's not what it is. So, when you have more than 1 polyatomic ion in the formula, you put parentheses around the ion, then you put how many of that ion outside of parentheses. Are we good? Okay, next one. Sodium fluoride.
You don't know what that is?
Huh?
You know what number that is?
Oh, I'm sorry, that is number 7. Okay, number 7 on the sheet. All right, once again, we need the formula, so we need the symbol and the charge. Okay, sodium. Na plus 1, because it's in group 1, it's going to lose that 1 valence electron, end up with a positive 1 charge. Okay. Fluoride, IDE. Everyone look on page 226 for a second. IDE should tip you off that it's on the periodic table, but there are 3 exceptions. On page 226, there are 3 polyatomic ions ending with IDE, and they are peroxide, hydroxide, and cyanide. Okay. So other than these 3, if you see IDE, it's on the periodic table. This is a lot to process. So that's why I'm reporting this, so that when you're doing the homework, if you get stuck, and you will, we all do, I did, you can pull up the video, run through how much of it you need, and get unstuck.
So,
Hopefully.
fluorine,
Hopefully I'm covering everything.
is it fluorine?
Yeah, that's a fluorine atom.
So what's the point in the ID?
Yeah, it's just what they do, in chemistry. If the anion is a single atom from the periodic table, they name it IDE. I don't know why, they just do.
Should make it easy to learn.
You don't know. But this is easier than what they used to use. They used to use Latin names for the cation. But they're trying to get people away from that. Pharmacy and chemical companies are slow to come around, but they are coming around. Okay, so you look on 17, group 17, -1 charge, right? Okay, how many of each do we need to get a stable compound? 1. So the answer is in red. Yeah, let me point out something else. Y'all, everyone look up here. That's the symbol of a single isolated ion. I wrote the charge. So is this one, right? But when I write the formula for a compound, we do not put the charges in. Okay. So this is the answer. This is just scratch work. When you get where you're real comfortable with this, eventually some of this you can do in your head, and that's fine. But if you can't, do scratch work. I do, and I've been doing this for 25 years. Okay? Okay. Number 8. Aluminum bromide. Okay. Once again, we need the symbol and the charge. So, what's the symbol for aluminum?
AL.
AL.
It's got a +3 charge.
+3 because it's in group 13. Good. Okay, bromide.
BR is got a -1.
Can I show you a shortcut? Now, there's 2 steps to the shortcut, and you have to follow both of them to make sure it's right, because it doesn't happen often, but it's almost like when everything's going really good and you don't expect something to go wrong, what happens? Something goes wrong, right? Okay, you've got to check this, because once in a while, you'll have to simplify the subscripts, okay? Here's the shortcut. Not the sign, but just the number. The shortcut is to take the number of this ion charge and make it the subscript for the other ion. And then that's a 1. That is going to be the subscript for that ion. So we write it Al1, and we don't write 1, Br3. Now here's the catch. Remember, this chemical formula is simplest ratio of ions, cation to anion. So you got to check and make sure that this ratio of ions doesn't simplify. 1 to 3 does not simplify, so we're good. That is the answer. Well, we don't write the 1, but it's AlBr3. Number 9, beryllium sulfate. Okay, beryllium. Symbol and charge. Be. Positive what? 2. Look and see what group it's in. On periodic table, it's in group 2. Okay. Do not assume. Look it up. Okay. Okay. Remember, ATE, what does that tell us? Page 226, polyatomic ion. So find it. Okay, and how many O's? Okay, now, we can do, I want to do the shortcut. That becomes this subscript, that becomes this one. Be2. All right, look right up here. See that 4? Never changes. And here's why. That never changes. It's you don't do anything to it. It stays the same. So that polyatomic ion symbol that you look up, you don't change anything in it. So what is the ratio of the ions? 2 and 2. Will it simplify? Yeah. So we simplify that to 1 and 1. So the answer is Be. And if there's only one polyatomic ion, you don't need parentheses. I won't count all if you did use the parentheses, but the convention is, we only use parentheses if there's more than one ion. Okay, number 10, cesium sulfide. Okay, symbol and charge. Cesium. Okay, CS is in group 1, plus 1. Okay, sulfide, look right here. IDE, it's sulfur. Good. Switch. What's the symbol or the formula? That's it. That's 2 to 1 will not simplify, so that's it.
Do you have to do that cross thing?
No, you don't.
I mean, 'cause
You have to,
Okay,
yeah, you can
yeah.
see, that's the thing, Angel. Some people can instinctively see that, well, you're gonna need two to balance that out. Yeah, that's good, just do that. But some people feel more comfortable with the crisscross thing. So you do what works for you. The only thing I care to see is what's in red.
Miss Cindy, I need Michaela down office, please.
Yes, ma'am. Michaela? Let me write down the assignment. Does anybody have a way to get a hold of Destiny? Can you? Okay, I might need you to text her and let her know what the change in the homework is. Let's see how far we get. Okay.
I'll probably be out for like 3 days if they suspend me. I'll probably be out for like 3 days if they suspend me.
Very good. See this practice?
Yeah.
We'll give that a try. Have a good day. Okay, here's your assignment. Everyone go to page 225. I wanted to cover D block, but I don't really. Oh no, we're good. We're good. Hold on, y'all. I'm thinking. Okay. All right. Homework. Due Tuesday. Everyone on page 225. Do you see that practice set? Do you see that it's underneath a sample problem called sample B? Okay, so I call that practice B. Okay, practice B, numbers 1 and 2, and page 227, practice C, 1 and 2. However, this is, and I'm gonna write in red what I need you to text to Destiny, okay? What does omit mean?
Don't.
Yeah, leave it out. Don't do 1E and 2 A and E on practice C.
What do we do with the paper? The one that we do.
Hang on to it so you can use it to kind of refresh your memory if you need to. On Tuesday, I almost forgot. What do we got next Friday? Friday, we got element test, name, spelled correctly, symbol, written correctly, for atomic numbers 1 through 25. All right, so what I'd like, we got 5 minutes left. I'd like for you to work in your study groups, help each other, learn the material, learn how to do this stuff. If you got a question, holler at me.